Okay, now let's take a look at expected value. Expected value is an average. It's a long-term average. If you repeat a process or an experiment over and over and over again, many, many times, what is going to be the average outcome? That's what the expected value means. To find the expected value, you're going to take each of your x values, multiply it by your corresponding probabilities, and then this sigma tells us to then add all of those up. To find the standard deviation of a probability distribution, we can use this formula here if you want to do it by hand. I can tell you that it is pretty tedious and it's a lot of arithmetic and it's very easy to make a mistake. It's actually not that hard, it's just long and tedious. So to save us the hassle of all the arithmetic and save us the time, we're going to use GeoGebra for this. If you want to try it, go ahead, but I'm going to be using GeoGebra. Okay, looking at example 4, it says an organization is selling raffle tickets that cost $10 to raise money. Based on historical data, 1 in 100 tickets win a $500 prize, 1 in 200 tickets win a $1,000 prize, and 1 in 500 tickets win a $5,000 prize. When we're calculating expected value, it's really a good idea to organize the information in a chart. It makes it a lot easier. So let's list out all the values for our first column here. This is from the perspective of the organization. So if they don't have to give out a prize, the cost of that $10 is going to be a plus for them. That's going to be a gain. So if they don't have to give out a prize, they get to keep that $10. If they have to give out a $500 prize, then they're going to have to pay out $490. They've already taken in that $10, so they only have to pay out the $490. If they win $1,000, that's going to be a payout of $990, so that's a loss to them. And then the same thing goes for the $5,000. That would be a loss for them of $4,990. Now, let's look at the probabilities that go along with each of these gains or losses. It says there's a chance of 1 in 100 to win $500. So 1 in 100 as a decimal would be 0.01. To win 1,000, that's a 1 in 200 chance. So that's a 0.005. And then to win 5,000, that's a 1 in 500 chance. So that's a 0.002 probability. So in order to figure out the probability of them not having to pay any prizes for this one here, all of those probabilities need to add to 1. So to figure that out, I'm going to take 1 and I'm going to subtract 0.01 minus 0.005 minus 0.002. What's left over is going to be the probability of them not having to give out a prize. So when we do that arithmetic, we're going to get that the probability of not having to give a payout is 0.983. So we're going to put that here. Now for part A, it says compute the expected value for the raffle outcome. So to find the expected value, we're going to take each of the values in the first column and multiply them by each of the probabilities in the second column. And then we add them all up. So we're going to have 10 times 0.983 Then we're going to add that to negative 490 times 0.01. Then we're going to add that to negative 990 times 0.005 plus negative 4990 times 0.002. When we multiply and add all of that up, we will get a negative 10. In part B, it says, interpret the expected value in terms of how much the organization can expect to make or lose if 10,000 tickets are sold. So the expected value that we got in part A, that represents long term. If we sell many, many, many raffle tickets, on average, long term, we're going to lose $10 per raffle ticket. So if the organization sells 10,000 tickets, then if we take 10,000 times a loss of negative 10 per ticket, that's a loss of $100,000. So long term, if the organization sells 10,000 tickets, they can expect to lose about $100,000. So in this case, the organization should probably reconsider the cost of their raffle ticket to make sure that they're making money instead of losing it. Now, let's go ahead and find the standard deviation. We're going to use GeoGebra. Okay, now that we're in GeoGebra, I want to make sure that I have my spreadsheet view up, and I also want to keep my algebra view up too, because that's where I'm going to put my commands. So I'm going to come over here, and I am going to choose View. I don't need the graph right now, so I'm going to uncheck that. I'm going to check Spreadsheet View. Another thing I suggest that you do while we're actually in here is go to Settings, and make sure where it says rounding, you're out the farthest you can go. It's much better to have as many digits as possible than to be short on digits and run into rounding errors. So make sure you have as many digits as you can, and then click Save Settings, and then you can exit out. Now, to check our answers for expected value, we're going to put in column A our X values and column B our probabilities. So in column A, I'm going to have 10, then negative 490, and then negative 990, and then negative 4,990. It's important to remember the negatives if you have them there, or else you're going to get a wrong answer. Then in column B, I'm going to put the corresponding probabilities. So I'm going to put in 0.983, 0.01, 0.005, and then 0.002. Because I have 13 digits as far as rounding, you'll have extra zeros there, but that's okay. Now, to find expected value, to check your answer, click on your command area and start typing in mean. Remember, expected value is a long-term average. So that's what we're finding. We're finding an average. We are going to use for expected value this second one down here where it says list of numbers and list of frequencies. The numbers are your X values and your frequencies are the probabilities. We need to put in the list of numbers. Those are our X values, and we're going from A1 to A4. So I'm going to put in capital A1 colon capital A4. That's our list of our values. Then I'm going to hit the comma button. And now I need to put in my list of frequencies. That's the values in the B column, our probabilities. So I'm going to put in capital B1 colon, and we're going to B4. So B4. I'm going to hit enter. So you can see GeoGebra did that arithmetic for us and found that our expected value is -10. Now, to find the standard deviation, we're going to do the same process, but we're going to use the standard deviation command. Now remember, there's two standard deviation commands. You could do the sample standard deviation or you can do the population standard deviation. Because we're working with a probability distribution here, that is everything. So we're going to be using, when we're finding the standard deviation for a probability distribution, we're going to be using the population standard deviation. So I'm going to start typing in STD, and that will bring up standard deviation. The first one here is for the sample. The second one with the P is for the population. And we're going to choose that second command down here where we can do the values and the frequencies. And I'm going to do the same thing. I'm going to tell it that my values go from A1 to A4. And my list of frequencies, that's my probabilities, that goes from B1 to B4. Then I'm going to hit enter, and it's going to give me that my standard deviation for this probability distribution is 238 if we round it to two places, 0.96.